Okay, we're going to go through kind of a few steps just to get our first libgdx project up and running. You can do it like we did in the lab class and simply go through the instructions on the libgdx website. Then you can get the Java file from me and get started through that. Then you can simply select your own project names and such, but this time I'm going to go through it by importing a project that I already made. So I put a project here under other material, project files, for Gradle import for base project. So it'll be named something similar to this, and I've already downloaded the file there, which is this file here, lab1. I've put it into my workspace folder, and the next thing I'm simply going to do is to extract the entire thing here within my workspace. I get this folder lab1, and this is a good time to change the name of the project, because when I grade your projects and I load a whole bunch of projects into my workspace, it's nice that your name is actually in the project name, so I don't just have 10 different lab1 projects with no way of knowing which one is which. So to begin with, let's simply rename the folder itself, the original folder here, and I'm just going to put my full name and my email identity, and then lab1 or assignment 1 or program 1 or the name of your game, whatever identifies your certain specific project, but have your name in there as well. Okay, the second thing I'm going to do, rather than import this now, even though I can change the names of the projects themselves inside Eclipse, the better way to do this in order to keep all dependencies solid is to go into the build Gradle file here, find the spot where it says app name right here, and I'm going to change the project name here. What happens then is that this project name becomes the base project name for the core project and the desktop project and the Android project and so on and so forth, by only changing it in this one place. So let's save that. And at this point I can go back into Eclipse. Now, in Eclipse, I go to File, Import, I select Gradle, and under Gradle, Gradle project. Okay, here I already have this folder, but you can browse for it, or you can just type in the name of the folder. Once you have the correct folder here, you need to build the model in order to actually get the projects that are in there. Now for you, this might take a bit longer. If you're doing it for the first time especially, then it's gathering a whole lot of dependencies and getting the original zip file with the Gradle scripts and such. So here I get the projects. This is the base project and this is core and desktop. Under that, simply select all of them and finish. And again, this here might take a while if you haven't downloaded all the dependencies yet, but in my case I have them all already on my computer, so it just finds them and sets up the projects. We can see that the name change I did, it doesn't matter for the project names whether I change the folder. The only thing that matters is that I change it inside the build.gradle folder file, and that has to be the build.gradle file in the base folder, not inside the core project or the desktop project. Those link to the other one. So what I have now is core here, where I have all of my source code, which is the game file now, and we have the desktop project. And one thing, if you don't change the name beforehand, you load it up and you have just lab1 here and you want to change it afterwards, that's okay. You can go to refactor and you can do rename. However, in the desktop project, this asset folder here is linked to the assets folder here, meaning that it's the same data in both places. If you change the name of the project afterwards, these links, so go to properties here, look at this, this has a location, project lock ... core assets. It needs to be this. It might change when Eclipse is trying to keep the dependencies correct and actually end up with a wrong folder name there. You can edit that, you can edit it back to this, but even if you edit this, in some cases you'll still have weird stuff happening, and you'll still have kind of folders that don't sync. So if you end up with that and you're getting errors because it can't find the files and it can't find your shaders, in any case you might have to go back and just recreate your project, either regenerate it with the GDX, either regenerate it here with the GDX setup, or go get my base project again and Gradle import it correctly and change the name inside the build Gradle file, build.gradle. So in any case, what you want at this point is to have your name in the name of the project, especially if this is an assignment that you're going to return to me. I need your name here, and you want to be able to go see that the assets folder here and the assets folders here are linked. Go to desktop launcher, run that as a Java application, and have something appear. This is nothing except a big window here with black in it, because we're not actually drawing anything, but we have a working program at this point. Now, the desktop launcher, let's just look at that now. It's basically just a starter class for your desktop project. The code that draws stuff is all in the core project. I've added some lines here. It's all in the first lab assignment, so I'm just telling it the size of the window and the label of the window. So I can add something here, my name, and save this, run it again, and we have my name up here. No big deal. Now the main class that we're going to be looking at, and in the end when we do projects you're going to have a lot more classes than this, but those classes are going to be classes and helper classes that you make in order to not have all your code inside the same class, but this is always going to be the base and the entry point into our projects. So this extends this application adapter, and the application adapter keeps track of specific functions for us. The main ones to begin with here, create, which is basically where we put all code that we want to run beforehand. Here I'm loading the shaders, I'm setting up the variables that I'm going to use to send information to the shaders. I'm loading a couple of matrices here and setting them up for the matrix variables in the shaders, setting color, and I'm loading this array here. This array is simply an array of 8 numbers, which are our first very simple two-dimensional vertices. The vertices are minus 50, 50 as an x coordinate and a y coordinate, minus 50, minus 50, minus 50, 50, 50, minus 50, and 50, 50. So we can imagine that these coordinates look something like this. If we have 0, 0 here, and this would be the length of 50, it's simply minus 50, minus 50, minus 50, 50, 50, minus 50, and 50, 50. So these 4 coordinates here, going 1, 2, 3, 4. Okay, and then we're putting this into a buffer here, and later on we can manipulate that buffer and ask OpenGL to read from that buffer the coordinates and thus send them to the screen. Here we have a render function, and the render function, while the create function is called once in the beginning of the program, or we can set it up so that it reloads in the beginning of levels and such, but for now the beginning of the program calls create once, then it calls render every single frame. It simply calls render again and again and again as often as it possibly can until we close the program. So render is our rendering loop or our game loop. And every single frame in the animation that we're going to draw is one call to render. Now I've split this up into update and display. So we have the update function here, the display function here. It doesn't really matter whether you'd put all the code inside render or not. It'll just make it easier for us to keep track of the code, the different kind of types of code. Display stuff here, OpenGL, the pure graphics where we're drawing the frame. But before that, we call the update function, which takes our speeds and our accelerations and adds them up to find new positions for everything, new positions for the camera, new positions for the objects, because they're moving through space in the computer game. And so the update function updates their positions. The display function takes their positions as static information and draws it into a single static frame. These frames being drawn again and again and again is what makes it a dynamic animation. Now, I have here the original lab assignment, and we'll just take a few things from that here. Like so, let's start with this. Put it into the display function because this is display code, this is graphics code. This over here, and so we have clear color, which is simply saying us this is the color that we're going to clear the screen with. This is the red part of it, this is the green part of it, and this is the blue part of it. This is alpha. Let's just keep that at 1 for now, but experiment with these values. 1 is full intensity, 0 is no intensity. So values between 0 and 1, experiment with that and make up your colors. So clear color can be here. It could also be in the create function, because we only need to tell OpenGL once what color we're going to use to clear. This function, however, is the function that actually does the clearing, clears the screen, and we need to call this function every single frame before we draw our data into this particular frame. So let's see what happens now if we run this. No, we don't want to run that. We want to run the desktop launcher. Okay. Okay, so what changed is that we have this nice sky blue color here that we're clearing the screen with rather than the black color. Other than that, nothing much has happened. We've already looked at this. I'm going to skip parts of this here, drawing a triangle, and just go straight to this part here. Actually, let's grab this, put it into our program, set the color, then let's go ahead and take all of this, put it in the program as well. Okay, so we're setting not the color to clear the screen with, but we're sending the color into the shader that the shader should use to draw whatever thing it is drawing at this point. Here we're simply putting new values into the vertex buffer. We already had some values in it, so we can actually skip this code if you want to experiment with it and simply draw the -50 to 50 box that we originally had. What we're doing here is we're sending again into the shader the data that it's supposed to draw. That is, we're setting up what's called the position location here, which is the location of the buffer that gives the position of the vertices that are supposed to be drawn. And we're sending this vertex buffer into that. Then, because this isn't actually drawing anything, this is only setting a pointer to where stuff is supposed to be drawn from, which vertex buffer it's supposed to be drawn from. Here we're actually going to draw from the vertex buffer. Now, this vertex buffer could be more than just 4 vertices, and we could start drawing from any point of it. But what we have here is 0 tells us where in the buffer we're going to start drawing, in this case at the beginning, and then it says how many vertices are we going to draw. we're going to draw 4 vertices, which are the corners of the box that we want to display. This last thing here is interesting because it could be triangles, and it could be triangle strip, and it could be a few more things, but for now let's look at the difference between these things. It's basically how does OpenGL go through the vertex buffer and use the vertices that are in it. So I'm going to go over here and get a little bit of an explanation on that. So what we basically have is the vertex buffer has vertices in certain positions. Let's imagine we have not only 4 but 9 vertices rather than the 4 that we have in the vertex buffer in our program. So these vertices would be here, 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, and 8. So those are 9 vertices indexed from 0 to 8. And if we call OpenGL and tell it to draw GL triangles, it'll take the first 3, 0, 1, 2, and it'll make a triangle. Then it'll take the next 3, 3, 4, 5, and it'll draw a triangle. And it'll fill these triangles out. Then it'll take the next 3, we had 0, 1, 2, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, and it'll fill that triangle out as well. So we'll have 3 triangles that we get from these 9 vertices. That makes sense. However, if we use triangle strip, OpenGL will, instead of taking 3 and 3 together and making 3 triangles out of 9 vertices, it'll take 0, 1, 2, then it'll take 1, 2, 3 and make a triangle out of that, and it'll take 2, 3, 4, 3, 4, 5, 4, 5, 6, 5, 6, 7, 6, 7, 8. So it'll end up making 7 triangles out of these 9 vertices. So this is a way for us to set up data on the surface of a model, or in our case the box, where we don't have to repeat constantly vertices that are parts of more than one polygon or more than one triangle. So we can see that the box that we're going to be drawing, which is minus 50, 50, minus 50, minus 50, minus 50, 50, 50, minus 50, and 50, 50, they will be drawn with triangle strip like so, filled in, and then like here, and filled in. And because they're filled in, they'll just look like a single solid box to us in our program. So let's see what that looks like here. Make sure that we actually get this to run. Okay, so we have a box. The box is down there in the corner because it's going from minus 50 to 50. And our corner is down here in 0, 0. Now if we want to move this someplace else, we can either use the code that we already had here and put different data into the vertices. So now it's going from 250 to 350, and run this like so. Okay, so now the box is in a different place simply because it has different vertices, different coordinates for the vertices. Another thing we can do, and what we will do very soon in the course, is rather than changing the data in the vertices, changing the coordinates, we'll actually change the coordinate system that we're drawing into and draw the same coordinates. So we don't have to constantly tell OpenGL, here are new and new and new coordinates. Instead, we'll use the same coordinates and center our objects in 0, 0, but we'll move the coordinate system that we're drawing into. So we can draw the same coordinates, but still get them to display in different places because we're moving around the matrices and the coordinate frames and the coordinate systems that they're being manipulated with. Okay, but let's stick to this for just a moment more. Go down here and add this data here. We're adding a bit of motion to this. I'm just going to add this way up top here inside the class, make these class variables, and let's set them to some values just inside create. Position x equals 300 and position y can just start in the same place. Alright, and then we're going to grab this code here and just put it right over this, like so. Shouldn't change much really. Okay, so it's still in the same place since it was already centered in 300. What we can do now is to change it. We don't have to change all the vertices. Instead, we simply have to go up here and say, okay, I'm going to put x a bit further out to 450. I'm going to put y a bit lower to 200. Sorry about that. I need to find a way to do this quicker. Okay, so now it's in a different place. The more interesting thing here, though, is not just to put it in a different place this way, but to actually be able to manipulate this position and get it to draw the triangle or the box or the vertices in different places each frame. So now we're going to kind of actually see how libgdx is running this render function constantly again and again by simply saying, here we're going to make updates. And the first update we're going to make is to say position x. We add to that let's say 2 per frame. Let's see what happens then. So inside our update function we simply say position x adds 2. And what happens is that every single frame that is run, 2 will be added to the position x, and the box simply moves smoothly off of our screen. So then of course you can say something like, if it's already off the screen, if the x is bigger than this or smaller than this, then it stops, or then it turns around and position x becomes, minus equals rather than plus equals, so on and so forth. But the main thing is that something is happening now. Another thing we can do is to go in here and say position x equals gdx dot input dot get x, and position y equals gdx dot input dot get y, and we do it inside this input function here. So a lot of functions on input, just check them out. We have just touched, we have is button pressed and is key pressed. Button is for the mouse buttons, key is for the keyboard, and more things like that. So just look at the input and see what you can do with that, and use these if functions to make a little bit of logic. If you push this button, it moves this direction. If you push another button, it moves another direction. Experiment with that. Right now I'm just taking the mouse coordinates at this current point. You don't even need to do it inside the if loop or inside the if statement. You can simply do get x and get y to get the mouse coordinates at any time. So you can use the mouse to move around or look around or strafe or do whatever you want. However, let's see what this looks like. Remember that. Okay, so I'm gonna use the touchscreen here. I can poke at a lot of places and the box moves around. However, I can show it to you with the mouse, and you see that it's not actually going at the exact spot that the mouse is at. the x coordinates are working, the y coordinates aren't. Now, this is simple enough. There's a function that you can use, which is called gdx.graphics.getWidth, and another one gdx.graphics.getHeight, which simply give us the width and height of the current interface, the current window that we're working with at this point. So you can take that height and you can subtract from it the y coordinates that you get, and the reason for this happening is simply that we are working in OpenGL in a coordinate frame that has 0, 0 down here, whereas Windows, which is giving us the mouse coordinates, Windows is working in a coordinate system that starts up here with 0, 0. So the x coordinates are the same, running from left to right in positive, whereas we're drawing where the y coordinates are going from bottom to top positively, whereas we're getting mouse coordinates sent to us where the mouse coordinates or the y coordinates are running from top to bottom. So all we have to do is take the height, subtract from it the y coordinates that we get, and that'll be the correct coordinates. And you're going to figure out doing that yourselves. Okay, so that's one thing. We've got the input rolling, and after that you should just look at some of these functions here. A lot of interesting stuff. Experiment, experiment, experiment. And same thing if we go back in here, doing the updates in the game. If we do the same thing that we did earlier, position x plus equals 2. If we instead put that inside an if sentence and say if gdx.input.is key pressed. Okay, is key just pressed is basically, was the key hit right in this frame or right before this frame. Is key pressed is just asking, is the key down now? So is key pressed means that while we hold the key, this will be true. As soon as we release it, it'll start being false. And now we need gdx dot, let's see what we got for these constants. Yeah, it's the instance input dot keys dot, I can find I think up or left or something should be here. Left would be just the left arrow key. So let's just stick to that. Like so. That'd actually be wrong to have it left here, so let's make it minus instead. And run the desktop launcher. Okay, so I can press the left button and it goes to the left. The other buttons don't really do anything. Okay, but now we've got something going, and all you need at this point is just to add more logic. If you're going right, it goes right. If you're going left, it goes left, otherwise up. If it's gone too far somewhere, then you stop at the edges, so on and so forth. And then just experiment. One thing to remember, especially if we want to add things, if you want to click the mouse on the window, and it not only changes the position of a box that's already there, but adds a box, then you have to remember that you can't just do that code inside the render loop or inside that current render loop. You need to actually stock up these different boxes. You have to have a vector of boxes or an array of boxes somewhere, and it needs to be either a class variable or some kind of globally accessible variable. And then each time the mouse is pressed, you have to add to that a structure that has a position, and then when you draw, you have to draw all of them. You can't just draw the last one. and add that to it, because you're clearing the screen in the beginning of every single frame, so you have to draw everything. So if you're adding something, you need to add it to your model, and when you get to the next display function, you have to make sure that you draw all of them, not just the newest one. So at that, I think we've gone through everything that's important in actually building these simple projects and getting the first assignments done. Then just make sure that you have your names here nice, and in the end, when you when you return your projects, you should just be able to go and take this folder here, which is now a single folder and has the core and desktop Gradle projects, these Gradle build files. Should be able to zip this folder just with the name that it already has, put that into the My School system, and I should be able to unzip that, Gradle import it, and your projects should work perfectly on my computer that way. And one other thing that you should definitely experiment with is both different colors and multiple objects in the screen. So we're setting the color here, although this is inside the create function. So setting the color here would mean that we're going to use the same color throughout the entire program, which doesn't really make sense. So we don't need a color here, but we want instead to set the color here where we're doing it as well. Inside the display function, which is part of the render loop, we're going to set the color here. And what we're doing when we set the color is we're simply taking these values and we're saying these are the values that are supposed to be set to the color variables in our shader. And once we've set those variables to specific values, they'll stay unchanged until we set them again, meaning that everything that is drawn after we call with this color will be drawn in that color. Right now we're just drawing one single box each frame, but if we were to simply copy this code and double it, and while I'm doing it, I'd like to stress that this is not a great way to do multiple objects. That is, the fact that I'm putting data into the buffer again, new data into the same buffer, and then asking OpenGL to point to it again. What we will have to do every single time when we want to change buffers is that we ask OpenGL to point to different vertex buffers so that it knows where it's supposed to be reading the vertex data from. And if we're drawing different objects and different models and different parts of a world, we're going to have OpenGL pointing to different buffers. However, we don't want to be loading those buffers with new data every single frame. So here we're taking this position, we're adding and subtracting values, and we're putting that in the buffer constantly. The correct way to do this would be to just load this with data in the beginning of the program, like in the create function, and then the position X and the position Y would be used to manipulate where it's being drawn, not what vertices are being drawn. Manipulating the coordinate frame and the world that we're drawing into, rather than manipulating the data itself, meaning that there's less data that we have to send down to our graphics hardware every single frame. However, we're going to do this way for now, for these first small projects, but after that we're going to do it differently, and we're going to, well, hopefully never do this way exactly again. Let's, well, I could have copied this, but let's just stick to this. So here I'm simply putting data again into the same buffer, and then after I put it in, I'm asking OpenGL to point to that buffer again. The reason I'm asking it to point to the same buffer again is for it to actually refresh the data that it's reading, otherwise it just used the same data as it had before. And then we're calling draw arrays triangle strip again. Okay, we can look at what happens if we just run this. I'm never going to remember selecting the desktop launcher before I launch, but let's see. Okay, so now we have two boxes. One of them moves when we press the left button, just as we did before. The other one is just there. What we now want to do is to say, well, to differentiate properly between these two boxes, we would like, before we draw it, we can put it here if we want, or we can do it just before we draw and say we're going to put a new color in here. Let's just make some strong yellowish color or something like that, and see how this looks. Okay, so now one of the boxes is in this color, the other box is bright yellow, and obviously we could keep doing this over and over, copying this code, or better yet, using these numbers that are already in this buffer, and instead of actually doing all this like so, and this, we should simply be able to say we've already loaded loaded values into this array here. So the buffer has these values, -50 to 50. What we want to do is call one of the functions that we have here below, where we're setting different values into the model matrix, and the model matrix is part of our shader, and the model matrix manipulates the data and the vertices that we're sending through the shader. And so we should instead be able to say, okay, what I'm going to do here is I'm simply going to call set model matrix translation to position X and position Y, and before we call it again down here, we're going to say set model matrix translation to 300, 300. And this isn't a great translation function. It just sets these values again and again. What we want in the end is a function or a way to manipulate the matrices so that we add every transformation on top of the previous transformation. So if we add another translation, it would be added to the previous translation rather than overwriting it. And so we can do multiple transformations in series and then back up some of them and then go on, in order to have kind of a stack or a link system of transformations that we can work through. But for now we're just doing it this way, and let's see where this takes us. Alright, what we were doing wrong is we never actually ever called obviously we at some point have to tell OpenGL where it should be pointing, and so we get this. Alright, so what's happening now is that rather than filling this data again and again with values, what we're doing instead is we're simply setting the translation, that is setting the point at which should be the center of the drawing that we're going to draw, and then we draw the same thing. So in both cases we're drawing the exact same box, but we're telling the shader to use a different color, and we're telling the shader to use a different translation matrix, which puts it in the end in a different spot. And so the only thing we need to do in order to draw more boxes is to simply copy this, say let's put some of them up here, some of them lower, some of them way out there. Let's see what we've got. We have 3 boxes here. There should be a fourth, but it's probably ended up in the same location as another one, which is this one here. This is to hide to be anywhere. In the screen. So there. Anyway. And in any case, we could then take the colors and say, okay, we're gonna put a color in front of each and every one of these boxes, or in this case 2 and 2 of them will end up in the same color. And so this is what we get. And then each of them can have different variables to move them around, and you can make a whole vector, a whole array of structures, data structures, that keep track of where a box is and what its speed is and where it's moving, and then you can update that entire thing in every single frame. So you could even add as many of those as you want, keep track of the speed and direction of each and every one of them, and then just loop through them to check where they are, check if they should be changing speed or changing direction, and then when you go into the display function, loop through every single one of them and draw them in the color that they're supposed to be and at the location where they are. So their data structure would need to have their position, their speed and direction, and their color, each of them in little vectors of data. And that way you can basically keep track of a whole world of interesting data rolling around in your little graphics program. So I think that more or less covers interesting stuff that you should experiment with and play around with in this first lab assignment and for the first assignments, and just to get you properly going using libgdx to do OpenGL graphics programs.